Okay, so this is rational expressions. This will go along with our delta math that's assigned, and that delta math is simplifying radicals and multiply and divide radicals. Okay, so a rational expression is just a fraction that contains a polynomial in the numerator and the denominator that can also be a monomial. So we need to figure out, how do we evaluate these rational functions? Well, it's pretty easy when they give you a value. So if you have an equation such as this one, which is rational, it's a fraction. It contains variables in the numerator and the denominator. Then you will just plug in that value. So like right here, it's wanting you to evaluate the value of f of 60. So that you just plug in 60 for x and solve. And the value that is spit out will be your answer. So this is the graph that is that equation for that rational expression or function. So when you get that, you plug in 60 here, right? And it spits out 195. So at 60 on the graph, the y value is 195 right here. So that's pretty self-explanatory, and if you want to solve this one yourself, you could. It's very similar to the other one. You just plug 40 in for that value. When you plug in 40, it's 80, which means it's in terms of thousands, so $80,000. Down here, we're going to figure out, how do we find the domain of a rational function? Because we have something that's down here on the denominator, then we can't have that denominator equal 0. So that means that those values of x that would make this denominator 0 are not included in the domain. So there's two ways that we learned at the beginning of the year to be able to write the domains correctly. Usually I'm not using set builder notation. I'm going to be using interval notation. But let's figure out, okay, we're going to set this domain or this denominator equal to 0 to find what the domain can't be. You are factoring it, right? So what values can you set that up to? Multiply to give you 36 and add or subtract to give you negative 13. Here are those values. Remember, these each have to be equivalent to 0. So that's going to be 4 and 9. Okay, so x cannot be 4 and x cannot be 9. So when you write that, this is the set builder notation. Then the function of the domain of all x's, x is a real number, and x cannot be 4 and x cannot be 9. Or write the interval notation down here. So you'll have 3 segments, right? Because it can go from negative infinity all the way up to 4, not including 4, from 4 to 9, not including 4 or 9, and from 9 to infinity, not including 9. So if you wrote that on a number line here, you'd have open circles, because it does not include it, and it goes from negative infinity, not including 4, 4 to 9, not including 4 and 9, and out to positive infinity. If you were going to think about this being written as a number line down here, okay? So to find the domain of this, you're going to set 2x plus 5 minus 3 equal to 0, like down here. You're going to factor, you get your two values. And then again, you're going to say from least to the greatest, right? So for negative infinity to negative 3, not including 3, from negative 3 to 1/2, not including negative 3 and 1/2, and from 1/2 to infinity, not including 1/2. Okay. We'll talk a little bit more about asymptotes, but these are values that the rational expressions or graphs can approach and not touch. For vertical asymptotes, but for horizontal asymptotes, it is possible for them to cross or touch, but they are going to be approaching that value on the horizontal asymptote. Okay, we'll get that into that a little bit more, but not right now. How do you simplify rational expressions? So this is what's on your notes. Factor the numerator and denominator completely, and then divide by common factors. So you cancel those things out. So like here, we're going to factor the denominator. When we do, it factors into this. We have a common thing, x plus 1, so we cancel out the x plus 1s, and then we just finally have 1 over x minus 3. So here, how would you do that? This is on your notes, okay? So you would need to factor the numerator this time. So you have x and 5 and 2, right? 5 times 2 is 10, and they both add up to give you 7. X plus 2's will cancel out, so you just get x plus 5 for your final answer. And you have it worked out down here. Okay, let's do another one together. We have 2 to factor this time, so we have to factor the numerator and the denominator. So let's see, x and x, 5 and 3, right? It needs to be a -2, so we need 5 to be negative and 3 to be positive. Down here, we have 3x, and we have x. We have 3 and 1, essentially. So 3 times 3 is 9x, minus 1 is 8x, okay? So that's factored. What common factor do we have? Well, x plus 3, cancel that out. This simplifies to x minus 5 over 3x minus 1, and that is your final solution, right? Okay, so how do you multiply rational expressions? Well, this is easier. The easiest thing to do. So you're going to factor all denominators and numerators completely, and then you're going to cross out or remove any of those common factors and then multiply what remains. You go across the numerator and across the denominator. So one thing you might need to know is that a quotient, which is you divide, of 2 polynomials that have opposite signs are additive inverses, and the value is -1. So for example, if I have y plus 5 and I have negative y minus 5, those are additive inverses, right? So that should equal -1 when you divide them, okay? So this is a very, very big polynomial. They factored both sections of each of these rational expressions. So here we go. And then we have to cross out anything that's common, right? So this and this are common, this and this are common. The rest are not. So let's go and see what they did. Okay, so they crossed all those out. This is the remaining factors in the numerator and the denominator. So if you wanted to simplify it further, you could multiply that and get your final solution. We'll just leave it like that. Okay, so down here, same thing. They had to factor. So the 8y plus 2, they pulled out the 2. That's a common factor, and they factored the denominator right here. And here we have just a y in the denominator that can be pulled out. So we have a common factor of 4y plus 1, 3 minus y, and y minus 3. Well, I think that's an additive inverse, right? Because if you multiply 3 minus 1 by -1, you get -3 plus y. So you can cancel these out, and that becomes -1. So we'll see how that works down here. They did the same thing. So this becomes 2 times -1, which is -2 over y plus 3 times y. So usually you're going to write that negative outside of the fraction, which most of the time when I'm doing math, I'm assuming it's on the numerator. So like this, either form is acceptable. Okay, so how would you multiply this? Well, it says factor and get rid of anything that is common. So we have 2 parts to factor. We don't need to worry about this one, so we can just rewrite it, right? X minus 7. And then we're going to factor this. And we're going to factor this. Okay, so let's look at this one. 7 times 3, those are factors of 21 that can add or subtract to give me -4. So -7 plus 3. Okay, and then down here, this is a square minus a square, so we add and subtract, right? And the square is 4. So what is a common thing that we can get rid of? Well, x minus 7 cancels out, x plus 4 cancels out. So when you multiply the numerator across and the denominator across, these just are 1, right? Then we get x plus 3 over x minus 4 for our final answer. Okay, let's do this one together. We have 4x plus 8. We have 6x minus 3x squared. Well, here, both of these, we can pull out a common factor or, something. So this would be 4 times x plus 2. Down here, I'm going to pull 3x out. So here we have 6 minus x, right? So 2. What am I thinking? Sorry. So 3 times 2 is 6x. Okay, and 3x times x is negative 3x squared. Okay, so that makes sense. And then what are we going to factor this into? We have 3x and x. We have 2 and 2, I believe. So 2 times 3 is 6, and then minus 4, or minus 2 would give us 4. So we need it to be a negative 6. Okay, so that should work out, right? 3x squared minus 6x plus 2x is minus 4x. And then we get negative 4 out here. So this is a square minus a square. So we have 3x plus 2 minus 2, right? Because we don't have any middle term, that cancels out. Okay, so what can we cancel out here? We have the 3x plus 2's. Here we have negative x plus 2, or x minus 2 is, and 2 minus x. These are additive inverses. Cancel those out, make that -1. Okay, so now we can multiply across. So we just have 4 times x plus 2, right? Oops, and that's negative, right? Because we have that -1 there. And then we have 3x times the group 3x minus 2. So to get it completely in simple form, or the simplest form, you would distribute the -4x and you distribute the 3x through, and you would get your final answer. And I'm going to leave it in that form. So that should be what we get down here when they get done. Yep, we have the same answer as the notes. Dividing it just has another step in there. So just know that when you're dividing by a fraction, it's the same as multiplying by the reciprocal. So you change that to multiplication and flip it, right? And that's just the last term. You can't do that to the first. So if you're dividing, then you're going to switch this. You're going to come down here. You're going to change it to multiplication, and you're going to flip-flop these. Then you're going to factor just like you did doing the multiplication. And you're going to cross out values that are the same and simplify, right? Okay, so we have 1 to do ourselves. Okay, so I'm going to just copy this first part. That's a minus x minus 12 over 5x. It's going to be multiplication, and I'm going to flip it. So x squared minus 6x goes on the top. And then we have x squared minus 10x plus 24 on the bottom. So next step is factoring. Factor both things that we can. So let's see, we have 4 and 3 multiplies to be 12, right? And we need it to be a negative x, so we need to be -4 plus 3 over 5x times, factor out an x, we get x minus 6. And then down here, we have 6 and 4, which multiplies to make 24 and can make a -10, so those both have to be negative. So what can we cancel out? X minus 6, x minus 4. Multiply across, we are left with x times x plus 3. and 5x on the bottom. But we're not done because actually I should have probably canceled out that x here.